Okay, Assalamualaikum and hi to all. Okay, we meet again here for a video that have few examples that I would like to share with you, okay, in order to give you a better explanation on the topic 6, which is sampling distribution. Okay, you can refer to UKM Folio on the notes that I have already uploaded, and it is in our previous lecture. Okay, so this video is just will focus on the discussion on examples of question. Okay, so the topic is the sampling distribution. Okay, what is the skills that we need to develop in this topic is we need to learn what the sampling distribution of X bar. Okay, X bar is the mean, is when the sample size is large, and we want to learn the sampling distribution of X bar when the population is normal. Okay, now we look at the first example here, example 1. Okay, let X bar be the mean of a random sample of size 50. Okay, which is your N is 50. Okay, so your N is 50. Okay, from a population with mean 112. So what is this 112? Your mean. So how would you write this? Okay, this is your mean. So your mean, okay, I will write it down here. Okay, so your N is 50, and then your mean, okay, which is your mu. Mu for your X bar is, this is for the sample, equals to mu of your population, and it is equals to 112. Okay, and what else do we have here? Standard deviation of 40. Okay, standard deviation of 40. So okay, so now you're given standard deviation 40. Okay, so standard deviation that are given to you here. Okay, so we want to write on about on these standard deviations of your sample, right? So it becomes, okay, if you refer to the formula that is given in the slide or your notes, okay, this is what given to you, okay, equals to standard deviation divided by the number of your sample or your N. Okay, I write again the formula here. Okay, so equals to, so how much is your standard deviation given here? 40. Okay, 40 divided by, okay, square root of N, which is 50. So how much do you get here? Okay, I hope you are also calculating this as I go along with this example. 5.685. Okay, so this is all the information by using the formulas in the previous lecture notes. Okay, so then you can see here that you already answered for the first question, which is to find the mean. Okay, to find the mean and standard deviation of X bar. So you look here, X bar here is the mean of a random sample. Okay, a random sample, so only the sampling, not the population. So you find the mean when you say mean for the random sample. That's why we use this notation, which is U X bar here, but we know it's equals to mu of the population as well, so by the definition, and it is equals to 112. Okay, and here we see that standard deviation of X bar, standard deviation of X bar, like I write here, the notation is equals to the standard deviation, okay, divided by the number of your samples, which is 50. Okay, so we get this. So we already answered the first question. Okay, Okay, so we continue with the second question here. Okay, which is find the probability that X bar assumes a value between 110 and 114. Okay, I think this example also been given in the lecture notes, but okay, we still go through for this. Okay, choose another color. Okay, perhaps purple. Okay, the second one. Okay, find the probability that X bar assumes a value between 110 and 114. So probability, you look the wording here, probability that X bar. So you need to form a notation to denote that this is a probability of X bar. So how would we write this? Okay, look at the sample example in this question. Okay, the N is 50. Okay, so since the sample size is at least 30, right? It should be at least 30 or more than lah. Okay, the central limit theorem applies. What is it? The X bar is approximately normally distributed. Okay, so now we use the formula of the standardized Z. How would you write that? Okay, so P is your probability, right? So it is in between what? 110 and, okay, for your X bar and 114. Okay, next, what is the formula that we use for this probability? Okay, when we want to use the standardized one, we want to change to standardized form. Okay, so probability, okay, now we plug in the formula that you can refer to the notes, okay, which is 110, okay, which is your X bar, right? X bar, which is your sample mean. Okay, okay, now minus with your new X bar here. Okay, divided by your standard deviation of your X bar. Okay, and in the middle is your Z, because we want to convert to Z here. So the next one is, because it is in between 110 and 114, right? So 114 minus with your mu X bar divided by your standard deviation of your X bar. Okay, because we want to convert this probability into Z value here. Okay. Okay, the next step. Okay, so this is step 1. Okay, step 1. Alright, so the next one. Okay, so you just plug in the value. Probability, so 110 minus with what? You know that the standard deviation is 112. So divided by, what do you get here from the top? I mean the previous question, you already calculated, right, for your standard deviation of X bar and your mean of your X bar. So your standard deviation that you need to plug in is this one, okay, which is 5.65685. Okay, so it is 5.65685. Okay, and it is between Z, and here is again 114 minus 112 divided by 5.65685. So we consider this as your step 2. Okay, and then so after you plug in all these figures, so you should do your calculation. Okay, so how much do you get here on the left side of your Z? You should be getting negative. It's obvious here that 110 minus with a bigger number, you should be expecting a negative value here. So negative 0.35 over sorry, not negative, Sorry, my mistake here. Okay. So negative 0.35 is the one that you get. Sorry. Okay, after you calculate this, and this is between this value and the right hand side, you should be getting 0.35 here. Okay, so this is your step 3. You already get the value that you need to find from the Z table. Okay, so now this is what the problems, okay, that students are facing. When it comes to this part, okay, when it comes to this part, which is you need to find the probability of in between values. The right hand side, you have a value here, and you have a left hand side value also. So if you look here, okay, you have to find the probability of Z more than negative 0.35 and less than 0.35. So we need to look at the cumulative table of negative and also the cumulative or positive one. Both of these I have already uploaded at your UKM folio. So we refer to the table. Okay. And what is the value that you get from this table? Okay, so now we refer to this Z cumulative table. Okay. So you looked at, you need to find the value of, for your probability of Z less than 0.35 and also more than negative 0.35 here. So this is the first one is the positive table. Okay. So 0.35, it is somewhere here. Okay, it is 0.6368. Okay, 0.6368. So we jot down first 0.6368. Okay, now the another example is the another value that you need to find is negative 0.35. So this is negative 0.35. It is 0.36317. Okay. (0.36317). Okay, so you can just do your calculation straight away now. Okay, and you should be getting 0.22736. So this is how we solve for this question. Okay, for number 2. All right. So now we move to question 3. So find the probability that X bar assumes a value greater than 113. Okay, so it is quite similar, but this is a value greater than. Okay, so you just change the error, I mean the sign, okay, and also the value there. Okay, so number 3, probability of your X bar more than 113. Okay, 113. So how do you write this in the equation? Using the same formula. P, now we have only one side, right? Because it is less than, more than 113. So Z, now we want to convert. Once you put in this notation of Z, remember that you need to use the formula because you are changing, transform it into Z value. So Z, so remember it is 113, right? So 113 minus with your mean of your X bar, okay, which is this one, divided by your standard deviation of your mean of your X bar also here. So it becomes PZ more than 113. So you plug in, it is 112 divided by the same value also, 5.65 685. So recap, where do I get this value? Okay, look at the first example. We already find the value of the mean of your x bar, which is 5.65685 here. Okay, so we just plug in only. That's why it's quite similar to the previous question. Okay, so your PZ now, because you want to know the value of Z so that you can refer to the table, it is, you should be getting 0.18 here. Okay, so now you can refer to the Z table again to find the value of this. But remember, the table give you the value or the shaded area of the region that is lesser than Z. So once you get this question that require you to find a value of Z that is more than, so that's why you need to use probability 1 minus with probability of Z, okay, which is less than 0.18. Okay, why do I put here 1 minus with the probability of Z less than 0.18 here? Okay, if you remember that in probability, it is between 0 and 1. So the total or the sum of the probability, okay, of that event should equals to 1. Okay, and you want to, when you are given a shaded area value, okay, in this table, it is given the shaded area of less than 0.18, but you need to find for more than. So that's why you need to find the total of your probability, which is 1, and you minus with the area in the table, right? Because the table gives you only the shaded area of less than 0.18. Okay, so if it should be around bell shape also, because it assumes that normal population n is 50. Okay, so let's say this is 0, the middle one. Okay, so but mu here is 112. Okay, so this is the mean lah, the middle one. Okay, so assume that somewhere around here. So what does it mean when it said that the shaded value is given in the table is less than, which means that it gives you the shaded area of less than. So the total of your probability is 1, right? And you need to find for more than. Okay, that is why we need to take the whole of your probability, which is 1, minus with the probability of all this shaded area, which is less than 0.8 here. That's why we are doing these steps. Okay. Okay, now we look at this table. It is less than 0.18, right? Okay. Alright, so 0.18. Okay, 0.18, which is 0.1. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's around 0.5714 of less than. See this shaded area, it is for you to read for the area that is less than that value of your Z. So 0.5714. So we go to the example. Okay. So it is 1 minus 0.5714 equals to 0.4286. Okay, so you should be getting this one. All right, so now we are done with question number 3. Okay, so this is for example 1. Okay, now let's move to example 2. Okay, so example 2, the numerical population of grade point averages at a college has mean 2.61. Okay, and standard deviation of 0.5. So if a random sample size of 100, so your n is 100, is taken from the population, what is the probability that the sample mean will be between 2.51 and 2.71? So I expect you already have a clear view on what is the steps that are required for you to solve this question. Okay, come. We try to solve this together. So your solution, okay. Sorry. Okay. Our solution. Okay, the sample mean has mean of 2.61. So your mu. Okay. So it's not clear here, sorry. Mu x bar equals to your mu equals to 2.61. And your standard deviation, always we need to define these two main input here, your mu and also your standard deviation. So standard deviation, okay, of your x bar equals to your standard deviation divided by the square root of your n. Okay, so what do we have here? 0.5 divided by, okay, the sample size is 100, so obviously it is 10. Okay, so you should be getting 0.05. So we have already write the mean and also standard deviation. So now we need to calculate of the question. Okay, they ask you to calculate for the probability that it is between, that your sample mean will be between 2.51 and 2.71. So the wording here, the probability of your sample mean, which is your x bar, between 2.51 and also, so the middle one should be x bar, because the question is the probability that the sample mean will be between 2.51 and 2.71. Okay, so this is how you write it. Okay, probability of your sample mean between 2.51 and 2.71. Okay, so once you have write this into this equation, okay, so the next one, okay, you need to convert it into z value. So you need to plug in into the formula. Okay, same one. So now you're given here is 2.51. So you minus with your mu here, which is 2.61. Okay, divided by, you already calculated here, 0.05 of your standard deviation for your mean. So it should be between z here already, because you already plug in, because you convert to z. Okay, so the right hand side should be 2.71 minus 2.61, okay, divided by 0.05. Okay, so you should be getting the z value is between -2 and also 2. Okay, so we find the value from the z table again. So how we write here, it is less than 2, then also here it is z, we need to find for less than -2. Okay, so refer to the table. Okay, now so we look at this z cumulative table here. So the value that we need to find here is z less than -2. So we refer to the negative table here. So your 2 is 0.02275. Okay, so you write here 0.02275. So as you calculate, you should be getting 0.9544. So we already settled for this question. Alright, so we move to example 3. Okay, so An automobile battery manufacturer claims that its mid-grade battery has a mean life of 50. Okay, 50 months with a standard deviation of 6 months. Okay, I want you to look carefully at this section A and B here. Okay, let's look at easy, right? But different way of solution. Okay, so we have this mean of 50 months and standard deviation of 6 months. They don't give you any random sample value, right? Okay, so now look at this question. Okay, on the assumption that the manufacturer's claims are true, find the probability that a randomly selected battery of this type will last less than 48 months. So we know that the population is known to have a normal distribution. It is stated there, right? So solution for the A, okay, it will be your probability of your X, not X bar, okay? Because it didn't say for your sample, right? Okay, so your X less than 48. Okay, so you need to convert to Z. Okay, so Z, so this is less than. So you know that the formula is 48 minus with your mu. Okay, divided by your standard deviation here. So you can refer to our previous lecture on this. Okay, you use X to convert to Z because this is not a sample mean. Okay, so that's why you plug in your standard deviation straight away. So you see that this one, it will become P Z less than, so 48 minus with 50. So you just straight away divided by 6. So you should be getting here. So I think, wait before I close this. So this one, it will be P Z less than negative 0.33. Okay, so you need to refer to the negative table here. Okay, 0.33. So what do you get here? 0.3707. Okay, 0.3707. So that's how you solve for the first one. Okay, now the second one, B. On the same assumption, find the probability that the mean of a random sample, see, random sample of 36. So now we are dealing with sample. Such batteries will be less than 48 months. Okay, so for B, okay, you know that your sample mean is equals to mean of your mean here, and it is equals to 50. Your standard deviation here, okay, of your sample mean is equals to this equation, standard deviation divided by the square root of your sample size, okay, which is 6 over square root of 36. So obviously this is 6, right? 6 over 6, you get 1. Okay, so you see the difference here? So now only you try to find the probability of, see how you denote here, X bar. Okay, because this sample mean, okay, less than 48. Alright, so then we start to convert it to Z value. So it is same formula, almost the same. It's just that we put X bar here. So now your X bar is 48 minus with your mu X bar. No, not mu here. Okay, then divided by your standard deviation of your X bar here. Okay, so you should be getting P Z less than 48 minus 50 divided by 1. Okay, so it is actually equals to P Z less than negative 2. So because this is less than and negative 2, so we refer to the negative Z table. So 2 here is 0.02275. Okay, so it is 0.02275. See, so that is the difference between A and B, how you solve it. It looks similar but a bit different on the value of your standard deviation when you want to use that divided by your sample size. Okay, So I hope that this explanation give you a better view and understanding on solving the question pertaining sample distribution of mean. Okay, and we'll meet again in the next video. Okay, and stay safe and goodbye.